Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account.
Hi everyone, today we have with us Johanna Jochum, who is an instrument scientist at the research neutron source Hans Meyer Leibniz, which is close to Munich in Germany. Hi Johanna, how are you?
Hi Pranothi, I'm good. How are you?
I'm good. After recording this short podcast with you, I'm really excited to take a deeper dive into your science. And you as a scientist and getting to know more about all kinds of activities that you're doing. But let's start slow. So let's start by understanding your career so far. So tell us your career journey so far.
So I grew up in Austria, and after that, after finishing high school and everything there, I went to Switzerland where I did my bachelor's and my master's in physics. Mm-hmm. And actually something that I learned only much later is that, and what is really nice about my studies is that I didn't have to choose like a specific field of physics that I studied. Like everyone was like, yeah, but what was your specialization, like nanoscience or magnetism or that? So like, no, I just chose like the courses that I liked, and like I have a bit of everything, which I think is really useful in the job I'm doing now. So that's very helpful. Mm. And during my master thesis was the first time where I studied superconductors, which is like a topic that I'm still really interested in. Mm-hmm. And after my master thesis, I was first considering staying in Zurich, and I took a position as a research assistant in the engineering science in the metallurgy department, and I was working on bulk metallic glasses there. But while it was a really interesting topic, it was not my approach on how to do science, because engineers and physicists actually work really differently. It just felt really weird to me to like be working with completely different tools than I grew up with as a scientist, and I wanted to go back to what I learned to love during my studies. So eventually I moved to Belgium to do my PhD there on nanoscale superconductors, magnetism, and multiferroicity in the end. Okay. And during that time there, I got to know large-scale facilities and what science you can do there, like neutron scattering sources and synchrotron sources. And I thought those were such amazing environments to do science at. I mean, you're there 24/7, and you're just like surrounded by scientists and these crazy machines, and it's just so exciting. So after my PhD, I was like, yeah, this is like the sort of place where I want to work at. And this is how I got to the job where I am now. At the Hans Meyer Leibniz Zentrum in Jochum, close to Munich, where I work at a neutron scattering instrument called Reseda.
Wow, that's quite a journey. What's interesting for me is that you went through different departments. You started with physics with your bachelor and master, and then you did a bit of superconductivity there during your master. And then you also went to the metallurgy department. And then to Belgium. This is like the typical traveling scientist, but every typical traveling scientist journey is completely different. So that's really exciting. And now then you're at this neutron scattering facility.
Yeah.
So that is like, do you have like physics departments and chemistry departments and metallurgy departments and all of that? Or is it just a mixed bag of people working on these amazing facilities?
Also, the thing is, we're kind of part of the TUM. So at TUM, you have, there's like the physics department and everything, the Technical University of Munich. We're basically an institute that's kind of attached to the Technical University of Munich. So the physics department and everything is basically just across the fence.
Okay.
And we're a service facility. So you can apply, we have twice a year, so we have calls, but you can apply to do an experiment with the different instruments that we have. So you can write your proposal, you can write, okay, I want to do this sort of science, it's cool because of that, and I would like to do that.
Mm-hmm.
And then there's going to be a committee who decides, okay, which get accepted and which get rejected. And then you have the chance to come and measure with me or with all my colleagues at the different instruments. And it's always good before you do that to contact the instrument scientist and talk about, okay, what do you want to do? Is it possible to do this? Does it make sense? How do you best write your proposal? Because, well, we've been involved in this quite a bit and we know what you have to put in there to make sure that it gets through. But yeah, this is actually really nice because I get to meet a lot of scientists that way.
Wow, that sounds cool. So you mentioned a bit about your current research that you're doing, and it sounds really cool. It almost makes me want to go back to my life as a scientist. It really does. But where does your current research fall in this big picture of materials or nanoscience?
So in materials, of course, in that we study magnetic materials a lot. We could do like more bioscience as well, but since most of us, the scientists at Reseda, actually have a background in magnetism, we are basically focused on magnetic materials. So definitely material science there, studying all phenomena in magnetic materials and superconductors and everything. And on the other hand, with my nano background, I kind of am trying to combine this with the work I'm doing now. So I'm trying actually to see if I can use Reseda to measure nanostructures as well. And this is going to be my big challenge because it's something that is very difficult to do because in comparison to these synchrotron sources, you need more materials to measure with neutrons. So it's a bit more tricky to actually measure thin films because, yeah, usually you don't have a lot of material, several nanometers. It's funny when I talk to my colleagues who have always been working with bulk crystals. We're like, yeah, it's a small crystal. It's like a few millimeters big. And I'm like, yeah, I've measured like layers that are 3.5 nanometers thick. What are you saying?
Yeah, 1 millimeter is still quite a bulk material for a nanoscientist.
Yeah, it's huge. And yeah, it's really funny to have this comparison. But I think because of that, my colleagues and I, we really complement each other well because we have these different viewpoints on different things.
Right. That's really cool. That's really, really fun. And it does sound to me that you're doing a lot of really cool experiments or research projects, and you have been involved with a lot of interesting research experiments or research projects, so to say. This question is a tough one. I know it's a tough one before I even ask it. But if you have to pick one research project that you're most proud of or the most fun or quirky one, could you pick one and explain it to us in simple words in the section we call In Other Words?
Well, the most proud of is actually a project that is not very fancy or not very special, but to me it's very special. So,
okay, go on.
So because when I started working at Reseda, it was like, this machine is very complicated and it was completely new science for me as well. So I was like switching fields once more and I felt like I know nothing, which is always the case when you start out in a new field, and then you learn and you get better. And well, after like a bit more than half a year, I was like, this is really interesting. I'm gonna do this calculation, and I showed it to my colleagues, and he was like, wow, this is really nice. Actually, it's good that you picked this up, and you should not just keep this for yourself. You should publish this. And now I'm gonna try to explain what this calculation was about, and this is gonna be a bit tricky. So to do that, I'm going to have to quickly explain what a neutron spin echo machine does. So a neutron is not charged, so it has no electrical charge, but it has a magnetic spin. So it's a very nice probe to measure magnetic materials. And if you put a magnetic spin into a magnetic field, it starts to precess. And if you have a well-defined magnetic field, so you know how long it is, how strong it is, you know exactly how often it precesses. So in a neutron spin echo machine, you have a very well-defined field before your sample position and a very well-defined field after your sample position that is exactly the same, except the opposite way. So if you don't have a sample there, it's like winding up a clock. Your spin turns, and then it turns back again. But if you put a sample in there, the neutron might interact with the sample, and then for the second bit of magnetic field, it's faster or slower. So it doesn't turn the exact same number of times anymore. And this difference is actually how you can calculate then certain processes in your material.
Okay.
Now, if you want your neutron to process, you need a minimum magnetic field. Otherwise, you lose your neutron because you have the Earth magnetic field or other magnetic fields around, and you lose it. So the minimum time you can investigate depends on this. You need not to lose your neutron. So you're very limited when you come to short times. And when I say short times here, it's like to go below 1 nanosecond of time that you probe. But then there's a possibility to actually add another coil with which you subtract magnetic field. You still have magnetic field there, but you technically subtract it from the other field without losing the neutron. So you can actually get to shorter times without losing your neutron, which is really, really cool because it opens up a whole new range of times that you can study down to like a picosecond. So this is like 3 orders of magnitude, which is quite a lot.
Yeah.
And we did measurements for that already, but we never sat down and properly did the math. So it's like a really technical paper with just comparing the calculations and the measurements. But for me, it was like I really started to feel like, okay, I'm starting to understand what I'm doing. This is really cool. And this is when I really felt like I was starting to get my footing in my new position. And so this is like really, it's a really nice paper.
Yeah.
So I'm really proud of it. It's not high impact, it's nothing fancy, but it's really nice.
That is really cool. I mean, the way you explained it first of all, this is like a completely new world for me. Even if I have been a materials nanoscientist, this is like a completely new thing for me that you explained. And I can imagine why you picked this as the research project that you're most proud of. One of the most proud of, let me put it that way. But yeah, this is really cool. And the paper is out, you mentioned, or is it?
Yes.
It's out already.
Yeah. Yeah,
Okay.
It was published last year.
Wow, you must be really proud of it.
Yeah, I am.
Yeah, and I think a lot of researchers, everyone rather, has this one paper or one thesis or something where they are like, yes, now I have arrived as a scientist. I know what I'm talking about.
Yeah, exactly. And it's just like this piece, and usually it's not like the flashy paper or the really fancy one, but it's like this small thing that you did and that you're really, really proud of, and that everyone would be like, yeah, but why?
It's okay. They don't have to understand it. As long as we understand it, it's fine. It's close to our hearts. That's the most important thing here. They don't have to. You can focus on other fancy papers I've written. I'm going to focus on this one that gave me this feeling that I have arrived as a scientist.
Exactly.
That's really cool. So thank you for sharing that. And speaking of being a scientist, other than the research, which you clearly love, as I can see, and you're passionate about it, what other aspect of being a scientist do you like or do you enjoy?
Well, what I really enjoy is meeting people from all over the world because I mean, science is a really interdisciplinary environment. And so I've met people from all sorts of places that I never thought I would meet. And I've been to a lot of places where I didn't think I would go. I still have in Belgium 2 of my best friends. One is from Belarus, one is from India, and we're still in touch. And it's like, really, I would have never met them if I would not be in science. And even here now, especially because this is sort of a service facility where people come to measure, I get to meet people and help them with their experiments at my instrument. And it's just like just working together and this meeting different people is just really, really something I really enjoy.
That is really cool. Yeah, I enjoyed that as well as part of being a scientist. That's really cool. Yeah, these are the perks of being at a facility like you are at, right? Because then you get to meet different kinds of people, different niche fields, people from different parts of the world as well. That's really cool.
Not
That's
just
really
because I travel to conferences to go and see them, but because they're coming to measure with us. So
yeah, that's a lot. That's a lot of contact. And how is that working now? Let me ask you this, because right now people can't really travel, right?
yeah, that was actually a big issue for us. So we have not been running for almost a year because of Yeah, I mean, there's quite close quarters. You have these experimental hutches, which are really not very big, where you usually sit together with 2 or 3 people, and it's just something that it's not that easy to do that in a safe way. So now we finally managed to properly organize that. We will also do a lot of remote experiments via TeamViewer and all sorts of stuff, so that we are basically Zooming with our users, and they send us the samples and we install them and we do their measurements, and they can via TeamViewer then see and collect their data and everything. It's much less fun, and it's much more tricky, because some things you just figure out while sitting together and talking, and then suddenly it comes to you because you're just rambling about something else, and then you're like, oh wait, did we try this? And this is just something that won't be there. So I'm curious how well this is going to work.
Right.
And also sometimes like installing someone else's sample, like just to have it the exact right way and everything, is also sometimes a bit tricky. So I'm looking forward to measuring again, but it's definitely going to be a different experience, and there's going to be some new challenges. But I'm glad that that we are running again, and that we're trying to make this work with the remote experiments as well.
Right, that's really cool. And the reason I ask you this is because I mentioned Marjorie, who needs synchrotrons to measure her melting or amorphous ice. I think that's what it's called. And she needs to go to a facility like yours, or to a synchrotron for the X-ray stuff. And usually one could just send the samples, like the dry samples you could just send in principle in a safe way somehow. But in her case, the samples come with an enclosure, within an enclosure with the liquid nitrogen.
Oh no.
Yeah. And then she has to travel, or someone who knows how to handle these samples has to take them with them. So you can't just post liquid nitrogen and everything. That's not safe, and that's not going to work out. But yeah, I hope this situation gets solved soon, and it's possible to travel again. At least for the sake of experiments, just for the sake of science. That would be nice. So, Johanna, it sounds like your research experience has been wonderful so far. And I mean, you are still doing science and you are enjoying almost all of it or most of it. But if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here, okay?
Well, I think like most scientists would want like a permanent position and not being on these. Yeah, I mean, like on this postdoc sort of stage, everyone is like on short-term contracts usually. And this is like the point where you have to decide whether are you going to go for a professorship or are you going to leave for industry. Those are mostly your choices. There's very few permanent position in this middle state where you can stay a postdoc. Maybe you have a few students that you supervise, but you don't have this big research group. Because for me, for example, that would not be the right fit. I would be fine with like supervising a few students and having like a small group, but I don't see myself as like having this big sort of group. It's just the organizational issues that come with that. It's just seem horrendous. So it would be really nice if there would be like positions, like basically permanent postdocs, or this is something there's like at these facilities, for example, you have a few of these permanent positions. I don't have one. I hope I might maybe still get one. But yeah, I think that's why a lot of scientists are struggling with. This is, I think, also the point where you lose a lot of scientists, because there's just not a professorship for everyone doing a PhD. And also not everyone wants to be a professor really, who's a scientist, because as a professor, you're not doing that much science anymore. There's a lot of administrative stuff, a lot of supervising, a lot of teaching. But I mean, I don't know very many professors who still find time to be in the lab, for example. So, and that would be something I definitely miss. So this is like the biggest thing that is missing, I think.
The first wish. Okay, you have 2 more.
Well, the other one is like also a bit of a bigger issue, which is something that I have not been too aware of, which is the whole open science issue. I mean, you're probably aware of that working for a publisher.
That's fine. Go on.
But it's very difficult to make science available to everyone. There's a course, journals where you can do that. I mean, a lot of people now post their papers on archive, but there's no peer review for the stuff that is on archive. So there's like there's always a bit of take this with caution sort of thing that comes with the paper that you read there, right? Because I mean, anyone can post something there and no one has had a look at it. And I think actually that the peer review system is a good system, but then there's like open access fees are usually quite expensive, so not everyone can afford that. And of course, if you can afford it, you gain visibility, and if you can't, well, it's just your own problem, isn't it? And I was also doing this talk at the Deutsche Museum, and I needed to have the rights for everything I showed because it was broadcast on YouTube. And I noticed that, okay, like some of the stuff that I published, I actually don't have the rights to anymore, and I need to write to the publisher to have the permission to actually use it in a presentation that's going to be broadcast. And I was thinking, like, yeah, this is a bit messed up, maybe. It's like, I mean, I did this and I still have to ask someone else if I can use it. Or I wanted to use this very first plot of like the superconducting transition, or like just a screenshot of the very first of the Bardeen-Cooper-Schrieffer paper from the superconducting theory. And I mean, I had to contact the authors to get their permissions, but I mean, 2 of them are dead and the third one is like over 90. Obviously, he didn't answer, which, I can't blame him really.
Yeah.
But so it's very difficult to like get access to certain things or get the permission to use certain things. And I think that's a bit of a shame. And I have no solution to this problem, but I think it's a problem.
Yeah. I think no one has like the silver bullet sort of a solution to it. Everyone is just trying to find a way to make it work somehow. I mean, I would say from the publisher side that it's going towards this open access, gold open access, the Plan S and all of that, working together with the funding agencies or the universities or like the societies and stuff, trying to find the right solution. But I'm sure we will find a solution that's at some point. That's your second wish. Do you have it? Sorry.
It's not just, I mean, with that, it's not just the papers that you publish, but also the data. For example, at these large scale facilities, a lot of data is accumulated, a lot of data is measured, but a lot of it is part of like a project from a PhD student who will not have the time anymore to evaluate the data, and eventually it gets lost. And there's facilities that do that. Like, for example, ILL has like an embargo on the data for 5 years. For 5 years, it's your data, and you can publish it. After that, it's being made accessible for people so that they can study the data and maybe publish it later on. Because, for example, 1 day of taking data at a neutron facility costs about 10,000 euros. And if that just gets lost because someone leaves science or something like that, would be just really sad, especially if like you write a proposal for a nice work, but someone else already measured that but never published it. It will not get accepted anymore because there's just not enough time to give out to do something twice.
True.
So there we also really need to work on how to make data available as well. And we started now doing with the papers that we published that we put the data and also the code that we used on Figshare, for example, which is like a platform that you can use you can upload all these code data and everything, and it gets a DOI. So you can properly cite it. Yeah, I mean, this is really nice because you can then have this data set. Okay, I'm citing this data set, I used that. And everyone can have a look at this data set later on and say, yeah, right. And you can also, it increases reproducibility as well, because like someone else can then take the same data and have a look at it as well and compare it to their own, for example, which I think is very nice. But this is also, it costs a lot of effort, of course, doing all of this because you don't get extra merit from it, but of course it's a nice thing, and for the community it's a good thing. So if everyone does it, it will be like a really great thing. But it requires quite a lot of work from a lot of people.
Yeah, it also involves a lot of changing habits, right? Uploading information there and publishing it that way. It takes a while to form these new habits and put the systems in place. And even after they are in place, it takes a while to convince people because not everyone will be on board with it. And it's just complicated things. But it's good to talk about these things. It's good to put these kinds of things on the wish list because that's when you would start working towards it. So that's the first one, is the permanent contract. Second is the open science, or handling the data hygiene. Let me just put it that way, if I may rephrase. Do you have a third wish?
I want shoes for the lab that don't hurt my feet.
Sorry, what?
We have these at the lab. We have to wear these steel-toed shoes because there's a lot of heavy equipment that could technically fall on your feet.
Right.
And these shoes are not very comfortable if we wear them 8 or 12 hours a day, I have to say.
Oh, that's not good. And these are different from clean room shoes, I guess, or?
Yeah, they're quite heavy and quite yeah.
Well, shoemaking people, if you're listening, take a note here. We need more comfortable shoes. Well, is it like a workout? Can we put a positive spin on it? Is it like a leg workout for you to wear these heavy
No,
shoes?
the only positive thing is that you can kick people without hurting your feet, but I'm not sure this is like
That doesn't count. Let's stick with the positives, that your feet won't hurt if the instrument falls on it. Let's stick with that. Well, all three very valid wishes, I must say. And I wish I could just say, Johanna, tomorrow when you wake up, everything is going to be like that. You will have your permanent contract. You will have all the data hygiene and everything, and everyone will know how to deal with it. And you have the most comfortable shoes. However, I would
it's
like
very
to
sweet
believe.
of you.
Thanks. I would like to believe that we are working towards it, especially the last part, because I think that is the quickest possible achievable wish list item, in my opinion, from the three that you mentioned, with the more comfortable lab shoes, which are also safe. But yeah, this has been wonderful. Your science is really cool and really awesome. Thank you for telling me all about it. But before I let you go, Johanna, one last question I have for you, regarding I can't not ask you about the year that has been 2020, even if I think most of us want to forget that year, but we all learned and unlearned a lot of things in that year. So, would you like to share some of your learnings from the year that was 2020?
Well, there's the Zoom calls, of course, or the Zoom conferences, let's say. On the one hand, it's really amazing because there are so many more talks you have access to and talks you can see that are on the other side of the planet, and you cannot travel that much. It's A, not good for the environment. B, you will never ever get anything done anymore because you're always jet lagged. So it's nice that you have access to everything and you can watch all the talks all over the world. But on the other hand, all this social interaction that comes with a conference and where you go into the nitty-gritty details of everything, this is kind of missing, like the coffee talks or the drinks that you have after the poster sessions and stuff like this, where you're like, we totally should try this. We should do this. Like, let's, and this is where you make plans and where you make collaborations. It's not during the talks where people try to be like then asking polite questions and everything. But no, it's like later on when you're having drinks and you're like talking about science, like in a more relaxed sort of atmosphere and very, yeah. And this is missing, and I really, really miss that.
Yeah, but in principle, online conferences to a certain extent can continue.
Yeah, I would definitely say so, because it was really, I mean, I don't know how well will it be feasible to have like sort of hybrid formats that to have a bit of both, because you cannot always travel everywhere. I mean, it's also like from an environmental standpoint, it's actually, these online conferences are a good thing because we've been all traveling much less last year.
True.
But still, from a scientific standpoint, I still think that you sometimes need a real life conference happening as well. So we as a community should try to find a balance there somewhere.
Yeah, a lot of collaborations and cool research papers come out of these coffee conversations or after hours, after conference hours, drinks. Tables. That's a lot of fun. Other than the socializing aspect, I think it's also very important for the science itself.
That's easily overlooked because you're like, but the conference dinner, but it's not that important. But It kind of is.
It is. It is. Now we know for sure that it is.
That is true, actually.
Yeah. Well, Johanna, thank you very much for speaking with us. This has been really, really, really fun. And looking forward to having you on Real Scientist Nano.
Yeah, thanks so much for having me. I was really enjoying myself. And I hope that next time I get to hear more about you.
Let's arrange that.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.